So just a minute. Yeah. So again, hello everyone. So today we have, Divyan, she is presenting, so she is having some data sets. So let's have a look at that. Yeah. Go ahead.
Okay, sir. So this is the complete data set for the kitchen appliances in which I have included. Sir, my voice is audible, right?
Yes, your voice is audible.
Okay. So like in this, I have considered four appliances. One is water purifier, second is mixer grinder, and third one is food processor, and fourth one is chimney. So like what I have observed, you can see from like rows number 4 to 6, I have not like my filtered is completely filled, nothing is happening. So on the like when it is operating without any filtering process, like it is still consuming some power. So 1.2 watt is consuming low. So sometimes people used to like forgot and turn on the filter, so there is some power consumption during that process also. So like when water is filtering, like we can observe the data till this sheet, like power is consuming till 22 watt. So this is the for the
How
water
do you,
purifier.
how do you know that filtering has started at the time?
So in my like water purifier, some signal is there when I am like certain, like when water is filling it up, one symbol is coming of filling the water, and when it is completely full, other another symbol come.
Okay, okay. So can you little bit can you magnify? I think on the lower right corner there is a facility to magnify. Yeah. Okay. So good. So this is now consuming how much power? 22 watts of power it is consuming, which is, which is not too low or too high. It is a good significant amount. Okay. So and then the power factor also is 4.6. Anyway. So what is the next appliance?
Okay. Next is a mixer grinder. Like in this, I have considered like without like switching on any operation. So this is like consuming only very less power, 0.4 watt. Then like in our mixer grinder, I am having three speed knobs. So at first I have operated for the first knob. So this is the data, and like it is consuming about 295, 286. This is the power we can see, and here power factor is 0.97. And when I increase the speed to the second knob, like power factor increased by 0.01, and this power also, sorry, power factor increased by 0.01, and this power also increased from 308, like 301 to 95, and slowly it is like coming down. Then at the load, when I just switch on the node 3 knob 3, sorry, like you can see till here, this power has increased till 348 watt, and power factor also increased by point zero 0.01. And like then I just
Yeah, so very good. I think there's a clear step we can keep seeing in this, that from
huh,
one set of switch to the other. Yeah.
yeah,
Anybody have
then
any
I
questions, feel free to jump in and ask your questions. Okay.
Yeah, and so like till here, like from this to this, I have considered my mixer grinder to be loaded. Then I like emptied the jar and like I run it empty. So what I observed is like when without load I am doing it, power is like 204 at at node 1, and then I increase the knob, power has increased to 242 and like 224, like it's varying. And again at speed 3 it is 257, 256. So this data set is for like when my jar is empty and it is at no load, and above one at load. You can see this part is for the load one, sorry, this one. This is when I am having load, and this is when I am not considering any load. So this for the mixer grinder. Next come to the food processor. So like above 2 rows without any, like without I'm doing anything, without operation, when I just plug in my device, so it is consuming this much of power, and this is the values we are getting. And in this food processor I am having two speed controls, 1 and 2. So first I have done for the no load. So you can see these three rows. at speed 1, this is the power 124, 125, 126, and power factor is also like 0.88. Then I switch it, and these six results are considered at no load. And then I increase the speed at 2. So this is the data I received. This like power has increased from 196, and power factor also we are getting 1. So this complete data is at no load condition. Then I half filled my food processor jar, and I got this data. So this is at the half load. You can see the power is like increased from this at no load to this when my load was filled half. So that is 143, 142, 141 is the power, and power factor is like same. Then at speed 2, power also increased. You can compare from the no load. It is like at no load it was 196, now it is 209. And the third observation I made in this, like I completely filled my jar, that is it, I considered as it as the full load. So you can see the power, like this is the result. So now power has, like at no load it was 124, and at half load it was 142, now it is 148. So like power is increasing when like we are filling up the load. So this was the observation for the food processor. Last observation I made for the chimney. uh, you can see here, like this was without, like just I plugged in my device, and like I'm just checking what is the power is consuming. So 1 watt is consuming in the idle state when nothing is, like nothing, no operation is considering. Then I like operated my chimney at power mode 1. So you can see this is the power consumption, one like 123, this one, like this 123 watt is consuming, and power factor is 0.96. Then I just switch
I
to
think,
the power.
I think now we can understand. I mean, from the this thing. So, any questions anybody is having on this? So definitely you should be getting some questions, right? Just I mean, although I can ask many questions, but I would like to give chance for others to first ask questions. Yeah, anybody wants to clarify something or you have any question?
So no questions. Shall I like stop presenting?
I have a question.
Sure.
So, what is the duration for your?
So like you can see, like for mixer grinder we can't operate like for long. Like I have operated for like one like if you can see at this one speed, like I have taken like three observations as per our code, because like we can't, like I am just mixing some, like I am grinding something, so I can't run it for a long duration to take the readings. So just for the few 30 seconds or 40 seconds I am operated for individual mode.
What about food processor?
So food, same thing with the food processor. Like it, like I had taken some, like I put some vegetables to chop them out. So like when like it is completely chopped, not like then I have to stop it. So that's the reason I have like operated for some seconds only, so that I can got some few 3 to 4 readings.
Okay, okay. So you said you wanted to try more appliances, right? What are the other things?
So one was refrigerator and one was toaster. I left. Like I was just want to make the complete kitchen appliances set, and one was microwave also. But microwave like plug is not, like I have to change that switchboards, plug in that switchboard. So that is left. 3 appliances are left.
Okay, so you can still try that, and even if you are not unable to upload the data, are you? If you can interface with this any monitor, you can see on the screen that values, right? You can copy paste them into Excel.
Yes, sir. I did the same thing from the data logger only. I have like taken those data.
You mean the Excel spreadsheet or the Arduino that serial monitor?
No, sir. Excel, Google spreadsheet like that we have generated
So
like all.
if Google spreadsheet is not working, then you can always use the that serial monitor to get the data.
But sir, in this like whatever code we have written for that Arduino, like serial monitor, like data is not coming like values. It's like temp data. Some name are coming.
So probably we need to look at the code once again and print that into the serial monitor also. Then
Yeah.
it will because the same thing is going from there to the Google Sheet. Anyway,
Yeah,
so we'll
only we didn't give the command for printing in that serial monitor. That's why we are not getting. If we like apply those statements for that printing, we will surely get the data.
okay. So apart from this, I mean, did you find any what you call observation which is non-intuitive? So obviously, yes, one speed, next speed, and next speed there is going to be increased, for different appliances. So these things are expected. Did you find something which is unexpected and it was
Yes,
interesting?
like as like I used to work in kitchen, so I like observe one thing. Like sometimes what I did is like I just continuously put my water purifier on like for 24 hours. If like it is not filtering the water only. So some of the some of the power is still consuming. So we can like avoid those things by whatever data I have collected. I just thought on that only. Like sometimes I just my device is not working, like no operation is conducting, but devices are on, still they are consuming some of the load, that like phantom loading. Sir, we used to say that phantom loading, I guess. I didn't remember the name. Like some of the load still not when we are just plugging the device, some load are still consuming, so we can avoid those situations in kitchen or at our home. So this was my observation, like I thought of.
So, but then if the load is only 1 watt, if you just calculate how much it will cost per day, if it is only 1 watt, can you just roughly calculate how much it will be?
So for 1 watt, 24 hours is there, no? So like sometimes like you can see like we are for 24 hours, 30 days, like we are operating our device. So it will be like it will cost
So
some
let's
like.
say that's what. Let's say it is 10 watts instead of 1 watt. Let's say it is 10 watts. Can we calculate quickly? So what it will be? So I'll calculate 10 multiplied by this is watts, right?
Yes, sir.
Multiplied by this is in watts. So 24 if I do, then it is watt hours. And
Yes, sir.
divided by 1000 if I do, then it becomes kilowatt hours. So
Yes.
per day it is 0.24 kilowatt hour, and per month it is 7 kilowatt hour, okay, per month. And 7 kilowatt hour, if you even take 10 rupees, so it's about 70 rupees or kind of 2 rupees per day.
Yes,
So
sir.
I have considered I mean 10 instead of 1 watt. Here you see 1.2 watt, 1.2 watt, like that something. So
Yes, sir.
even if I consider 10 watts of power loss for 24 hours, 30 days, still the loss is coming around about 70 rupees per month. Okay. So with only 1 watt, it will be like 7 rupees per month.
So, sir, like this is for the particular one device we are talking. If like similarly we are having so many devices, like TV, sometimes we just plug in and we left it for like 24 hours. We like only shut it down from the remote. So like similarly, like few watts are like wasting. So we can like save those electricity, like those watt also, no? Like for
Yeah,
like this is like.
I'm not saying it is no saving, but then it is not that there is too much of loss.
Yeah.
It is still a loss, but then we just have to quantify it, and then accordingly we need to worry about. Yeah,
Yes, sir.
yeah. So anybody wants to ask any question, any other, anybody wants to show your own data, something like that.
Yes, sir. The data shared by Devanshi, it was very interesting and very intuitive actually. So actually, I have one question there. Devanshi,
Sure,
can you
sir.
please,
Yeah,
can
this
you
is the
please,
data. Yeah.
actually, can you please go to 35 row number?
This one, right?
Uh, yes. So sir, actually, I'm not getting this part. When we are operating it at a speed of 1 and 2, so the power factor is somewhat lower. But at speed 3, the mixer is taking a power factor is unity. So actually, I'm getting confused, and because theory-wise, it should be one for all the loads. If we are considering it at no load, then it should be one only for other also for other speeds. Uh,
Let me just think once. Yeah, like I have observed in like both the device and mixer grinder also and food processor also.
mhm,
So what I thought is like this, like when knobs are, we are just changing the knob position. Some might be, some might be I'm wrong. Like some low, that inner resistance or something might be
mhm.
varied. So might, sir will like give the proper answer, but might be my
Uh,
thought is resistance might be like changing inside internally in that mixer grinder and food processor. That's why when we
mhm.
are like increasing the speed, so no positions, like power factor is improving. I also observe for both the device, mixer grinder also and food processor also. You can see.
Yeah, but can we consider some inductive element in series with resistor, because the power factor is lowering a bit for other speeds, but for
Yeah,
uh,
yeah, that
resistor it
might
is
be the
showing
reason.
one.
Yeah, like yeah, that might be the reason. Like for like node
Mhm.
is increasing, it is becoming pure resistive, I guess.
Yes, yes.
Sir, what is your suggestion in that?
So one thing I want to disagree. You were saying that sir will be able to answer it properly. That need not be the case all the time. So it's not like whatever I tell it is correct. So, but then what I would like to say is, if you see, notice 1.99, 0.98, something like that, right? The variation is only within a few percentages, 1%, 2% variation in the power factor reading, right? Zero point 0.8. Of course, here it is 0.88, that is slightly different. And okay, water filter and all is again a different story. But as far as you are considering mixer grinder and all, it is the variation is not much, and therefore we need not comment anything about it. See, if there was a 10% variation, if there are 20% variation, then we need to see what is the problem, what is the reason. But for such
Oh,
small variation at this, I mean, with the instrument that we are using, with the waste that we are doing, it is well within the margin of error, so no comment kind of thing on that. So that is my observation.
but sir, like we can see like in this like 0.97 is for like it is coming constant for speed 1, and 0.98 like completely constant is coming for the speed 2, and 0.99 for speed 3. So like why this is coming, that I also thought like complete, like in the food processor also we can set 0.88, like 0.8988, and similarly like 1 is coming for like completely 1 is coming for the speed 2. So something might be there, no?
Okay, so then have a look at the currents then. From currents, can you comment something? 1.2 to 1.3. How about the variation in the current and variation in the voltage?
Current.
The voltage is also varying all the time. You know, this is the what we are highlighted is energy. So that is not the this thing.
Okay, sir.
Yeah, but still, yes, there is some pattern. But then again, with that much little variation, I am not able to make a conclusion. So anyway, any other questions?
Yes.
Yeah. So let me share my screen. Yeah. Yeah. So this is the folder which from which the data is getting uploaded. So I think some people have uploaded. I mean, Funnyram has uploaded fridge data, refrigerator measurements. Okay, so Krishna agency, some data different people have applied. So this is your Excel file, and yeah. So I think Funnyram is present today, right?
Yes, sir. I'm present, sir.
I'm just opening. You want to present? That will be great.
Okay, sir. Fine, sir. I will present.
Yeah.
Yeah, sir. Here I have taken for 1 hour, sir, reading. I have monitored for 1 hour. Around 350 samples I have collected. Yeah, should I open, sir, or that is also okay, sir, if you display?
No, actually, you open it. I think.
Okay, sir. Fine, sir. Yes, sir. Is it visible, sir? So here I have collected data.
Yeah, I can see now.
Yes, sir. Here I have collected data for 1 hour, sir. 1 hour I have monitored the refrigerator. So around 350 samples I have collected. Maybe around 6 samples per minute or so. So if you see the patterns are here, the when fridge is in ideal condition, like it is constantly it is drawing 1 watt of power. Just here I have twice opened the door of the fridge, so it has increased it to 12 watts. And later when refrigeration action started, actually when it started, it has jumped to 69 watts, and again it has come back to 31 32 watts, like that. And it is there like that for 100 samples, that is around 15 minutes. So around 15 minutes this refrigeration action has taken, and then again it has gone into idle. So if you consider like this, in 1 hour, every hour 15 minutes, if it is doing refrigeration, per day 1/4, like 6 hours per day, we will have that 30 watts of consumption, and the remaining time it will be at 1 watt consumption.
Can we go to energy column once? Go to the starting first row. What is the energy column? That is column E, 0.2. And go to the last reading. 0.2 is the starting energy. And
Okay,
what is the last reading? Okay, still point. I mean, in 1 hour, it is just only 0.21 kilowatt hour.
Yes.
So now what I suggest is, this is very interesting. Can you plot the power column? Just select column D completely.
Yes, sir. The column D.
Column D, and then say insert menu, and then say chart, and then line. Just simple line chart will be fine, and then say finish. Or maybe again edit the chart. I think here you can go to the there itself. Yes, chart itself, and go to the next one. I think we'll get a line chart. Actually, basically what I'm saying. No, that itself in the chart itself. Go to the next one in the toolbox.
Toolbox. Okay, sir.
Otherwise, you delete it and reinsert once again.
Yes, sir. I will delete it.
Entire. Just select outside. What is you can just click outside and then say undo. It will go.
I will. That is also correct, sir. I will undo. Yes.
Yeah. So again B and then insert chart and then go for line and then line itself and select the third one. Third one.
Yeah.
Yeah. Finish.
So this is how it is. So this
So
is
here the door
this is
open
when
we can see at 18 and then
yes.
start of cycle we can see here goes up to 70 out stop.
Yes, sir.
So
Yes, sir.
if you do it, can you do this for 24 hours? And then
Yes.
I would like to know how many cycles is there in 24 hours.
Sure, sir.
And
Sure, sir.
also doing some data analytics. Can we identify how many door openings happened?
Okay, fine, sir. Sure.
Can you try that?
Yes,
And
sir.
what is I think you might have changed the ampere that plug we have to change or
No,
what you have
sir.
done for fridge?
It is 5 ampere plug only, sir. Fridge.
Okay, okay. So you
Hmm.
also upload the, I mean, you give the details of what is the model of the.
Yes, sir. Yes, sir. Sure.
I'll just come back in a minute.
Okay, sir.
Yeah, meanwhile, you can continue discussing. I'll just join back in a minute.
Yes, sir. Sure, sir. So I actually Vipul, Divyanshi, when if I have to keep for 24 hours, that problem may come no for me also that data logger my exhaustion will happen. I
Yes, sir.
have
Yes, Paniram. Like
so
what happened with me right now, like when my 1,000 column got filled, so I added like another 1,000 column. Then after I'm not getting any data. Like I don't know why. I try to like upload and compile my code again, but still not getting any data.
then we have to do copy it from serial monitor only then.
But in serial monitor, we have to change our code because you can see in serial monitor, we are like only getting some names, temp data, something like that. We are not getting any values. So we have
Yes,
to print those data.
correct,
No,
correct.
actually,
Yes.
there is one solution.
Yeah, tell me.
In We have two codes available with us. There was one first code in which we were plotting some data with
Yeah,
serial
yeah, got
numbers
it.
earlier. So if
Yeah.
we use that code, then we will get proper data, and then we
So
can export it
yeah,
quite
yeah,
quickly.
yeah. We need not that second code is to Wi-Fi, no. So we need not use the
Ah,
second code. Okay. So
exactly. So
we have to load first code and we will collect data. Okay, right.
yes, yes.
Yeah, that
Because
will
I'm
be.
also planning to go into that way because last time I tried to record the data. So after every half an hour, I had to monitor what exactly is going on, and it was not getting recorded actually. So I will also try that approach.
Yeah,
Let's see.
that will be okay.
Mhm. Mhm.
Now I have to shift my table near fridge or fridge I have to shift here because I have bunch of assignments also now.
That's interesting. So in 1 hour, how many cycles are there? This
Only
refrigerant.
only one cycle for 15 minutes.
Okay.
This is 180 liters refrigerator, a
Uh-huh.
small fridge.
Okay, old one or new one?
New one only 2020 model only, but small fridge, less capacity.
Okay.
Okay. Okay. So yeah, my suggestion is then definitely you should take a longer data. 24 hours you take. If not 24 hours, you take even more than that to maybe like 240 hours, like continuously data for 10 days. And I would like to know what is the what you call continuous this thing. So
Sure,
this
sir.
data set is fine. This is showing one pattern, like one
But in
one
1 hour, 1 hour. Yes,
yeah.
sir. Yes, sir.
So we'd like to see how it goes for more time.
Okay, sir. Yes.
So try for, I mean, try to keep it continuously, right?
Sure,
Um,
sir. Sure.
is there
Yes,
any issue
yes.
for that not doing that, or do you have Wi-Fi at your home?
Yes, sir. Is there, sir.
So then, if you configure the Wi-Fi and if you completely connect and leave it, the data
Yes.
will come, right?
Sir, only limitation what we are thinking is that spreadsheet, what we have, the data logger, it is getting exhausted, sir. That rows, that
Okay, then
memory issue
I'll
or
do one
something.
thing.
Yes, sir.
I'll do one thing. Let's try to address that today itself, and
Yes, sir.
we'll do some coding on that. Yeah,
Okay,
that
sir.
data issue we'll try to address today itself.
Sure, sir. Sure.
Yeah. So anybody else wants to ask any question or anything? Is this interesting?
So one more issue, sir. Since
Yeah.
uh, since the cables or wires that we are using right now for this circuit is of 1 square mm, if we connect it to
Okay.
the fridge and we want to take the readings for longer duration, that may be a bit dangerous. 1 square mm might not withstand the load of the fridge for so long. So that's the only.
Maybe my fridge is very small, basic model only. I think it
I
may
mean,
support.
that is not a problem. I monitored it for 1 month and nothing happened.
Who
Okay,
wanted 1 month?
that's very nice.
We need one,
Sir,
right?
you copied 64,000 lines of data, no, sir?
Yes. Yes. So
Yes,
what was
you
the
copied
appliance?
in
What was the appliance?
refrigerator, sir.
Refrigerator only.
Yes,
Good.
sir.
So then let's, if we'll check whether there are any what you call interruptions or things like that, and otherwise we'll actually make it into a proper data set and we'll keep it for
Sir, the data
down.
is with you only, sir. I mean,
Yes,
you
yes,
copied
I
into
remember.
some other sheet. Okay.
Yes, I remember. I think I will share that also with all of you.
Yeah.
So I just created one more sheet called backup, and then I've done that. Okay, so good. So any did you do any analysis, Vinay?
Sir, I haven't done much, but the same cycles came for every day. Like,
Let's see.
I
Let's see.
mean, yes,
I think I'll open that right now. Is your device on now?
yes, sir, yes.
So I'm sharing the screen, and your ID is 5, right? If I
Yeah,
remember.
yeah.
Okay. Okay. I'm sharing my screen, right? Okay. I'll go to Drive. And yeah, I think I got someone. So since the last time we cleared the data, whatever is there, let me just roughly plot it and then see. So I'm selecting the power, and then I'll say insert chart. And okay, so this is what I'm able to see. So we need to see what is the duration, but so clearly we can see some patterns like this, similar pattern, right? So any comments?
What is the capacity of this refrigerator? It is
I mean, it's a double door refrigerator. I think it is 10 years old. I didn't have that.
330 liter size, I hope.
Okay.
Double door means.
Yeah. I mean, sir, it is last 1 week data.
Yeah, if you go to the fridge, on that it will be written on the back side of the fridge. There will be a nameplate. In that every
Okay.
detail will be written. You just have a look at it. If it is nearby, you can confirm maybe in this call itself.
Okay, I will check in 2 minutes, sir. Okay.
Okay. So meanwhile, we'll have a look at the plot. Okay, so this is the entire data, but let me once again plot a subset of data and then see what happens. Okay. Okay, I'm just highlighting the row number 4000. Okay, so row number 4000 is
Hello,
highlighted.
sir. Okay. It's
And
200 liters.
300 liters and
200, sir.
200 liters. Okay, and 4500. Let's go up to there. So then I'll just highlight this. So I have highlighted row number 4000 and row number 4500, and then let me take the I think I'm sorry again so I'll just take some random values and then insert a plot, and then later I will change the data. So here data is 1274, right? So here I will take first of all I'll go for a line chart, and then I'll go for data range 4000 to 4500. Okay. So I think I'm getting one cycle and then empty, and another cycle again empty, another cycle again empty. So I think let's go back 3000 to 4500. So I'm able to see 1, 2, 3, 4, 5 cycles. Even if I go back to 2000, and then I'll just say, so yeah. Now here again we are observing one peculiar pattern. The duration of this particular cycle seems to be abnormally long. So we need to investigate why that is. And also just prior to that, also instead of 160, it went up to 192. So before that also this one. And also the duration of this particular gap is also less. Okay, so there are some abnormalities we are able to find in this. So we need to verify that. So meanwhile, let me also, what I'll do, I'll just convert the time and then check what it is. So what is the, anyway, for this data set, again, I'll go back to chart. So instead of 2000, I'll just go to 1000 and then 4500. Right? I believe there are 5000 rows at least. So let's see. Okay. So still looks good. Okay, we have 5000 rows. Okay, so rather than writing program about doing that, let's do some analytic on this 5000 rows. Okay, so any suggestions you want to suggest at this stage before going with the idea of doing some analytics on this?
Sir, sir, with every cycle there are some spikes also. Whenever a new cycle is
That's a
starting.
pattern we are observing everywhere. Even in the earlier case, when other student was presenting, I believe Vipul was presenting, right? We could see a spike there. So it looks like the fridge itself has a pattern like that. It gives a spike, then it goes down, then slowly it goes up, and then it comes down. So there are these
Yes, sir.
on cycle, off cycles, or something like that. So
Maybe when compressor starts, it may happen. So
yeah.
Hmm.
So the starting
Yeah.
of the compressor, immediately it takes huge current, and then within few seconds it comes down and things like that. Anyway, so shall we analyze this, or you have any other questions or things that we can discuss now, or if not, we will go with analyzing this.
yes, sir,
What
we
is
will we shall analyze it, sir. Hourly basis and day basis, we shall see this.
okay? So let's for in order to do that analysis, so let me take a copy of this data. So what I'll do, I'll just copy the entire set. Oh, in fact, I have 12,787 this thing.
Sir, in another sheet, we have much more data, sir.
Yes, yes. So for the time being, let's go
Okay.
with it. Yeah. So I'm sorry, the sound that you're hearing, my son is disturbing. So anyway, we can still continue. What I'll do now is I'll just go to a. I mean, we can actually do it in a proper way, but then right now I'll do only a crude way. Okay, so I hope everybody is now following. You'll be able to get some idea. So I pasted this data into a simple this thing notepad, and then maybe I'll just find everything tabs and then replace with comma. Okay, so all the tabs will be replaced with commas. So it will become a comma separated file kind of thing. So yeah, so looks like it's a comma separated file now. So now I'll save this, Control S, and then maybe desktop. I create a new folder. I'll say data analytics, something like that, and then fridge.csv. Okay, so I have now the CSV file with the data. Okay, so in the desktop. So next, what I can do is I'll open my terminal, and then I'll say cd. I think it's already. Okay, so cd, I'm going to that particular folder that is data analytics, right? So here is the file fridge.csv. Okay, so now we have that file. Okay, so I am not that much. I don't do this much regularly. So let's see how we can do some kind of analysis. So this I'll close. This also we don't need for the time being. And let's close this also. I mean, all unnecessary things I'll close. Okay, so this, I think I can keep this desktop and data analytics. So here is a file that we are having. So first thing I want to do is create a file. Okay, so this, we can use any editor. I'm just using for the sake of this, I'm using a simple Vim editor. I think what is it? I think okay. So I want to write a Python program. So let's see. I'll go here and then search for how to read CSV into Python. Reading and writing CSV files in Python. How to import CSV file in Python using pandas. So I think we will try to do that. Import pandas as PDF. First of all, let's see whether I have pandas on my system. Okay, so for that I'll open another this thing and I'll enter into Python. I think I have Python 3 also. And then import pandas. Okay, looks like it is working good. So I'll say exit. I can use this code. So I'll just copy this online code and then come to my this thing, import pandas, then df data frame pd.read CSV. Okay, I think I have to here I have to give the path. Okay, so already I had given I had named the file, right? The file name, what did I give? If I go back to this, fridge.csv. So I'll do it here, fridge.csv. And then, so it's a simple 3-line program. First line is importing pandas. Second line is data frame df equal to, I mean, you can give any variable name. Read CSV the function, and then I'm reading, and then I'm printing the data. Okay. So I'll just write this file. No file name. Okay. Run.py. Okay. So you can see on the left there is a Python program created. So now I'll quit from this and then I'll say Python 3 and then run.py. Okay. So see, I can see the data here. Immediately it shows the data. So I have some number 259.7. Apparently this is the voltage, this is the current. You know, all data is there. Okay. Now our Python program does not have a heading. Okay. So our CSV file. So I think it's opening in this this thing. I don't want it to open in that. But anyway, so Vim. I think I'll just cancel this or gedit. Oh, this is in a different path. So let me also give some headings, sir. Okay, so what are the headings? Can you say what is the first one? This is T-stamp, timestamp, then voltage, then current, then is it power, and this is energy, and this is frequency, and last one is power factor, PF I'll call it. Okay. By the way, am I audible? Is my recording still on?
Yes, sir.
Yes, sir. Yes, sir.
Because I did not hear anything. So why I am giving these headings is that because read CSV also has that this thing. Okay? So once again I will run this. So I have the like this, and here you can see it like this. Okay? So now if I go back to my program, let me go back to the program. Vim run.py. So instead of printing df, I can say df.power. Okay. So now if I simply save this and then if I run the program again, so only the power is coming. Okay. In fact, it is coming in a simple way. That means the first row is 6.2 watts, and then as we go, last row 12,000, this one, it has the power, and the length is this one, and data type is a float. Okay. So like this. Now this timestamp. Okay. So how do we convert the timestamp? Okay, so now if I go back here, instead of power, if I say so, I'll save this, and then if I once again run this command, so I'm getting the timestamp 16071 like this, and then this one. So what is the, shall we try to see what is the first timestamp and what is the last timestamp? Shall we try to do that?
Yes, sir. Yes, sir.
So now again, I'll go here, how to read first and last row of data frame. Because already we are in Python, the data frame is the this thing. Okay. So df equal to python.dataframe, pd.dataframe. Okay, this is creation of data frame. Okay, so df dot iloc 0 1 and then iloc minus 1. Okay, so let's try this. So I'll go back to my program, and then so I'll paste it here. So let's say first equal to like this, last equal to like this. So this apparently this will extract the first and last. Okay, so now let me print first and print last. So I'll write this, and then I'm sorry, I'll write this and then we'll run this. So so this is the first data frame, I mean first row of the data frame, and this is the last row of the data frame. We are getting both. Now I want to convert timestamp from whatever this thing. Okay. So if I want only timestamps, I can simply say here first dot tstamp and first last dot tstamp. So again I'll write this and then I'll run this. So here I'm getting the first timestamp and last timestamp. Okay, so that is fine. Now I want to convert it into what you call normal format, the human readable format. Okay. So how to convert epoch time to date in Python. Okay. So even in pandas also it is there. So let's see, convert Unix time to readable date. Okay. So let's see. In fact, I think it may be possible to completely convert all for all rows. Okay, so let's see. So pd dot to date time df date comma unit equal to s. Does this work? Call pandas to date time column. Okay, and then unit equal to s. So that will be converted. Okay, so I think I got it. So I'll copy this from here. I'll copy it from here, and then let me paste it here. You're following, right, what I'm trying to do?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
So let's say instead of saying converted df, I'll say normal tstamp. Okay, so or let's say n tstamp instead of n underscore tstamp. I mean, I'm just so this pd dot do date time that remains same, and instead of here date, I think we were using tstamp, right? And then unit is s. I don't know what the unit s means, but even if I don't know, it is fine. And here I think I don't know what we should do that. Okay, so n underscore. Okay, so I'll just print everything instead of printing the first one and last one. Okay. So I hope now this is clear. So now if I run the program, so I'm getting the first timestamp as 4th December 1907 and last timestamp as 18th December 1220. So today afternoon 1220 and this was on 4th December. So 4 to 18. Okay. Now I want to know whether there are any what you call gaps in the data. So if you notice here, there is 1944, 744, 744. Then again, the third data row is after 2 minutes, about 952, 952. So looks like the pattern is suddenly it will read 4-5 data records, but and then there is a gap of 2 minutes, something like that, right? Are you getting this? What I'm trying to show here?
Yes, sir. That may be because of delay, upload issue.
No, the timestamping is happening within that immediate 1 minute. There are 3 data points, and then again like that. So there might be a lot of redundancy.
Mm-hmm.
So anyway, so let's see. This is like what we call the cleaning of data. Okay. So let's see if I go back here, or is it because of S? Maybe what is this unit S? Okay, so I'm just reading the example. What does the unit mean? Okay, so Control F, unit. String default is ns, nanosecond. Okay. So I can go up to millisecond. I think ms is millisecond and us is microsecond. Let's go to a millisecond and see what happens. Because whether we have any other this thing. So I'll go here and then I'll go here and then say insert millisecond. So now I'll run this code again. So here now I'm getting a millisecond also. So okay, so even millisecond is same. Oh, I'm sorry. I think the problem is different here. 1970. Okay, I think this is completely some other wrong thing is happening. So I think we'll not bother about it. We'll go back to what was this. Of course, we can investigate, but then right now I don't want to do that. But in any case, what I want to do is I want to resample the data. Okay, so let's see how that happens. Here, how to add a column to a data frame. How to add a column to a data frame in Python. Okay, so here data is there, and then data frame whatever is there, address is there. Using address as a column name and equating it to the list. That's it. It will be added. Okay, so simple. So I have to say data frame of name equal to this. Okay. So what I can do here, I'll add this n timestamp to that this itself. So data frame square brackets in that single quote, and then say nt stamp. That means normal timestamp, or simply time. I'll say time equal to n underscore. So is that okay? Did you understand what I've just done? So now I'll just simply print df. Okay, so I'll just run it here. So here you see the output has come. There is a time column that is added in the end. Okay, so there is a regular timestamp, that epoch timestamp is there, and there is a time column also is there. So now we have the more columns here. Okay, so 12,786 rows and 8 columns. Is that okay? Any doubts up to here? Resample time series data in pandas. So what does resample means? Again, I just want to verify whether my call is being recorded or not. Am I there?
Yes, sir.
Yes, sir.
So I mean, I keep speaking, so I don't know whether. Yeah. So right now time is 5:18. So let's see in 12 minutes what more we can do. Now I want to do resampling. Okay, what is this resampling? Let's see. Resample time series data in pandas. Okay. So what is this? To simplify your plot, which has a lot of data points due to hourly records, you can aggregate the data for each day using resample method. To aggregate or temporal resample the data for time period, you can take all the values of each day and summarize them. In this case, you want total daily rainfall, so you will be able to resample whatever, okay, like that. So resample across day and then say sum. Okay? So the D specifies that you want to aggregate to resample or by day. Okay? So resample by day and take a sum, and then let's see what happens. Okay? So is that okay?
Yes, sir.
And what are this sum? Dot sum method will add up all the values for each resampling period. By the way, I don't want to sum up. I want to find the average. Okay, so in terms of power, what is the average power on a day? Okay, so let's see whether that thing is possible. Okay, so I'll go back to our fridge data. Okay, and then here in the code, what I'll do resampling. Okay, so first thing is I'll delete this. First row, all that things, because we know what is the first row, last row right now. So I'm importing pandas, then I'm reading the file, then I'm creating a timestamp and then loading it into. In fact, I can cut short this also. I'll simply say delete this, and then I will delete this. So this is what I'm doing. Okay. So our program so far, whatever we have done is only 3 lines. First line is importing pandas. Second line is reading the file. Third line is creating a time column and adding it into the data frame. Okay. Any doubts up to here? I've not done anything different. Okay. Now let's do resampling. Okay. So for resampling, what I should do? df.resample, will it change the df itself, or that's what I want to understand. Okay, so let's see. df.resample, and then I will say as per day. I don't know whether it will work or not. Let's see. df new. Okay, I'm just creating another data frame. So print. I'm sorry. I think I have done if. df.new. Okay, print df underscore new. So let's see what it will print. So what is the error we are getting? Where is the error message? Local Python traceback most recent call. Not an instance of R name. Okay, I think we have done some syntax itself is wrong. So let's do sum itself. Okay, and then see what happens. Dot sum. Okay, so I'll save this now. Only with valid date time index. Oh, that is the problem. Type error. Only with valid date time index, time delta index, or period index, but got an instant of range index. I think we need to specify index properly. DF date time index. Okay, so they're creating an index. Okay, I think the way I implemented there was an error. So let me read it properly. So here import pandas set data, get data file, read CSV. Dot head view first rows. Okay, about precipitation data. Okay, so these are all data is there anyway. Describe. I think let's try this before we do anything. Let's see, describe what happens. So I'll comment this for the time being. So hash will comment it. Df dot describe. So let me execute this. Okay, so once again. Okay, so nothing different. It is just the same thing: voltage, current, power, energy, frequency, and power factor. Okay, so let's go back here. View index values of data frame dot index. Okay. So this is plotting. So plot, we are right now not interested. Resample hourly data. Okay, to daily data. Df dot resample dot sum, where the D specifies. As you already have set the date column as index, pandas already knows what to use for the date index. Okay, I think we have to set as index. Okay, so that's what
the column we have to
set as index. Okay, so view index values of data frame dot index and date time index. Okay, so let's see if how to set index. Otherwise, we'll find out. Okay, so I think I'll go back to the program and then. Instead of describe, I will say print df dot index. So let's see, by default there is any index. Okay. So okay, so there is a range index. That's what 0 to 1 to 7. This is the first column, right? So this one 1 0 1 2. I think that itself is the index. Now I want to set the time as index. Okay, so how to set index for a data frame? Pandas data frame set index. Okay, so set index is there. So example I want. Set index. Setting the first name as index. Okay, I think set index we can use. So I'll go back and then say df dot set index. Is it set underscore index? Sorry. And here I will give time as the column, right? Because that's the time column which we just prepared. So slowly things are coming together. So now I'll go here and then if I rerun, so now did it work? It still says this. Df dot set index. Did I any other in place equal to true?
here when we are printing, sir, last line.
Yeah.
That again you have given dot index, no sir. DF
Okay.
dot index.
Okay. So you want me to say simply print df?
Yes.
I think the df will be whatever is the first column. The index will be the first column. So let me once again run and see. Okay. So time is still not coming as a first column. In place equal to true, append equal to true, drop equal to false. Yeah. So let's try in place also. So here set index time comma in place equal to true. Okay. So time has come to the start, right? The first column became the time, and then the last column became the power factor. So it works now.
Yes, sir.
Let's go back. So now I can do what I was doing, resampling, okay, on a daily basis. Df new and print of df new. Okay, so let's see what happens. So I am getting again some issue. Due to some reason, the time is going back to 1970. And 14, 15, 16, 17, 18. So here it is, oh, okay, now I understood. I think the problem is there might be some data where like this kind of data are there. So therefore, because of that reason, it is going back to, like, if they, I think 1970 1st January is 0. So for the timestamp of 0, it comes like that. Okay, so let's see. So I want to check whether any 0 timestamps are there in my data. Okay, so let me check that. But anyway, at least this is I can do one more thing. I can print it little bit more properly. So here you can see the total energy. Actually, this is wrong. We are supposed to get we should not add them. We should average them. Okay. So let's see how to average. Okay, so resample and average. So I think my kid wants to go home, and also we almost come to the end. So let's do the final step of averaging with resample. Yeah, mean is there. Okay, so mean. Instead of this thing, I'll use mean. Okay, so I'll go back here. Instead of sum, I'll use mean. So I'll say mean. So now if I run, so at least now I'll know daily power. So let's see. So on 15th December, the power is 68 watts. The average power of the fridge is 68 watt. On 16th December, the average power is 116 watt. 17th December, some problem happened. We'll figure it out, everything. And on 18th December, again, 118 watt. Okay. And energy also, this again, the difference between these two will be the actual energy. So for energy, we should not average them. So this is again meaningless data. But average frequency is correct. Average power factor is correct. Average current is correct. So typically average voltage for entire day is here. So we are getting the average statistics. Average current is also meaningful. So things like that. So not only this, we can do a lot of other things also. So before I close, let me do last one thing. Instead of day, let's say if I replace with H, what happens? Okay, so if I say H, will it take hour? Let's see. So yes, so the last, 9th on 18th of December, 8th hour, 9th hour, 10th hour, 11th hour, 12th hour. So I'm able to resample it according to that. So during that hour, it is 123, 116, 87. So good. So we are able to get hourly averages also. So again, this is interesting. So there's so much more we can be doing with this. So we'll stop the data analytics here because of the time is up. So next class we'll see. Any questions, any doubts you have? Okay, if yeah, Vipul, if nothing else, then I'll end here and then we'll continue. I think this is the last class, but anyway, I'll keep in touch with you on phone and then on email, and then we will see what further can be done. If at all I do any further work on this, I'll keep you updated. So,
Sure, sir.
so thank you.
Thank you,
Thank you,
sir.
sir.
Thank you,
Sir,
sir.
can you please stay back, sir?
Who is this?